Hello everyone. So in this video I will show you how to calculate the system design of a home DC lighting system using solar power as per the load required by the customer. I will show what components you need to buy from the market along with the rating of the components. I will show also how to do the connection step by step. Suppose this is the load which is required by our customer. So you can see that the total number of load is 4, in which 3 are bulbs and 1 is fan. You can see also the power of each and every load and the hour of operation of each load. You see that all the load are DC load. The fan also is a DC fan. The system that we are going to design is a DC off-grid system. No inverter is required in this system as there is no AC load. The components required for this system are solar panel, MMS, battery and charge controller. MMS, its full form is module mounting structure. We don't need to calculate a system design for this MMS because MMS, it is not a component. It is just a way or a design how to fix solar panel like you want to fix on the rooftop or on the ground. Let's calculate now the system design for solar panel, battery, charge controller one by one. First of all, we need to calculate the total load connected in watt-hour. So, total load in watt-hour is equal to number of load into power into hours of operation, which is equal to 5 into 2, in which 5 is power of bulb and 2 is the hour of operation, and so on. And after calculation, we get the result of 166 watt-hour. Now, let's calculate the panel voltage. But first, we need to calculate the maximum daily load, which is equal to total load in watt-hour divided by load efficiency into system voltage, which is equal to 166 divided by 0.8, which is the load efficiency, into 12, which is the system voltage. And after calculation, we got 17.29 ampere hour. Now, total current required is equal to maximum daily load divided by equivalent sunshine hour into charging efficiency into dust factor. Maybe you want to know about equivalent sunshine hours. Let's say the sunrise is 5 AM and the sunset is 5 PM. So the total hours is 12 hours. But unfortunately, we cannot get the sunlight on our solar panel for 12 hours because sometime in a day it is rainy, sometime it is cloudy also. We will just consider that in a day the equivalent sunshine that the solar panel receives is 5 hours. Now, total current required equal 17.29 divided by 5 into 0.9, which is the charging efficiency, into 0.95, which is the dust factor, and this is equal to 4.044 ampere. So the total panel voltage required is equal to total current required into system voltage into real panel voltage divided by the input panel voltage, which is equal to 4.044 into 12 into 17.82 divided by 12, and is equal to 72 watts. So the required rating of our solar panel is 72 watts, but the available rating of solar panel in the market is 75 watts, so we choose a 75 watt solar panel for this system. Now let's calculate the battery capacity. So battery capacity is equal to days of autonomy into maximum daily load divided by depth of discharge into discharge efficiency. Let me explain about days of autonomy. Days of autonomy is the number of days in which the battery can stand without charging. So days of autonomy if we use inverter is 2, and days of autonomy if we use DC lighting system without inverter is 3. So battery capacity is equal to 3 into 7.29 divided by 0.8, which is depth of discharge, into 0.85, which is the discharge efficiency, and is equal to 76.27 ampere hour. So the battery rating that we are required is 76.27 ampere hour. But the available rating of the battery in the market is 80 ampere hour 12 volt. So we choose a 80 ampere hour battery. Let's calculate the charge controller rating. So first we need to calculate the current from PV array, which is equal to maximum power of PV array divided by maximum voltage of PV array. So since the power of our solar panel is 75 watt and its voltage is 12 volt, so we put the value 75 divided by 12, which is equal to 6.25, and current from load is equal to total connected load divided by voltage of connected load, which is equal to 29 divided by 12 is equal to 2.4 ampere. So now we check which current has higher value, the current from the PV array or the current from the load. Clearly we see that the current from the PV array, which has the value 6.25 ampere, is greater than the current from the load, that is 2.4 ampere. Hence we take the charge controller rating as 6.25 ampere. But since the efficiency of charge controller is 75%, so while designing we will consider 25% extra current. So charge controller rating is equal to 1.25 into 6.25 is equal to 7.81 ampere. So the required charge controller rating is 7.81 ampere, but the available rating in the market is 10 ampere 12 volt. So we consider that the charge controller that we are needed in our system is 12 volt 10 ampere. Now let's calculate the cable sizing. So we will take that the distance from solar panel to the battery is 10 meter, and the distance from the battery to load also is 10 meter, and the distance between each load is 10 meter. So the formula for cable sizing is equal to P into rho into twice L divided by BD into B square into load efficiency, where P is power, rho is resistivity of wire, L is the length of the wire, BD is the voltage drop, and B is the real panel voltage. So size of cable from solar panel to battery is equal to 75, which is the power of the solar panel, into 0.02, which is the resistivity of the wire, into 2 into 10, in which 10 is the length of the wire, divide by 0.04, which is the voltage drop of the wire, into 17.82, which is the real panel voltage, into 0.8, which is the load efficiency. So after calculation we get 2.95 square mm, but the available cable size in the market nearest to this value is 4 square mm. So we consider that the cable size from solar panel to battery is 4 square mm. So now let's not waste our time to calculate the cable from one load to another load. We will use the same wire that we have calculated from solar panel to battery, that is 4 square mm. So here is our final PV system. We need to buy a solar panel whose rating is 75 watt 12 volt, the charge controller whose rating is 12 volt 10 ampere, the battery whose rating is 8 ampere hour 12 volt, and the wire whose cross-section area is 4 square mm. Now let's do the connection. This is our solar panel. This is our charge controller, and this is the battery. So from the calculation that we have calculated, we found that the rating of the solar panel that we are needed is 12 volt 75 watt. So let's check the rating of this solar panel. You see that the rating of this solar panel is 30 watt. So if we buy this one, we need to buy 3 of it, so that we will connect parallel and it will become 90 watts. But for this video, we will consider that this solar panel is 75 watt, since we don't have extra solar panel in our lab. And this is a charge controller. We can charge mobile also from here. This is the terminal that we connect to load number 1, load number 2 and load number 3. From the positive of solar panel, it will come here, and the negative of the panel, it will come here. The wire from the positive terminal of the battery will connect it here, and the wire from the negative terminal of the battery will connect it here. This is the battery. In fact, the rating of this battery is 12 volt 20 ampere hour. But in our calculation, we needed a battery which is a 12 volt 80 ampere hour. For this video, we will just consider that this battery is a 12 volt 80 ampere hour. This is a charge controller, and the rating of this one is 12 volt 10 ampere. In our calculation also, we needed like this one, so we will use this one. Now let's do the connection. First of all, we need to connect from this positive terminal of the solar panel. So you have to insert this wire into a slot and then tight a screw with the help of screwdriver. So from the positive side is done. And now we will insert the negative side. Insert it in a slot and then tight it with a screwdriver. Okay, I have inserted and then tight it with a screwdriver. So just to show you in this connection, I use this wire. In fact, we have to use the wire that we have calculated, that is 4 square mm. But just to show you, I use this one. So this is the positive terminal, and we will connect it with the positive terminal of solar panel. Practically, in reality, you cannot connect wire like this by twisting it. You have to connect it properly like this one using MC4 connector. And this is the negative terminal. Now the connection is done from solar panel to charge controller. In fact, from this solar panel, the wire need to go fast to array junction box, and from the array junction box to the charge controller. But here in our lab, we don't have array junction box, so we will connect directly from solar panel to the charge controller. Now let's connect the battery to the charge controller. You have to make sure that you didn't short circuit the positive and the negative of the battery. So this is the positive terminal and this is the negative terminal. So just to show you, I connect directly like this. In fact, we have to insert the wire into a lock, trim it and then fix it in a battery terminal using a nut. Now let's connect the negative wire from the negative terminal of the battery. So this is our positive wire. So we will insert it in a positive terminal in a charge controller. First we will trim it. Okay, now let's connect it. we have to insert it here. Let's loosen the screw first. Now insert it and tighten it using screwdriver. Now insert the negative also. And then tighten it with screwdriver. Now our connection is done. So now from load number 1 we need to connect a wire here along with one switch, and then from load number 2 another wire with another switch, and from load number 3 another wire with another switch. So that's the end of our video.